Hello students, so we'll start with the next topic, that is invertible matrices. Okay, so if there is a matrix A which is a square matrix of order m, okay, and if there exists another square matrix, say B, okay, of order same order, that is order m, such that this product AB is same as BA and we get identity matrix. Okay, then this B is called inverse of A. Okay, so invertible matrices. So if this condition is satisfied, then we say B is the inverse of A. Okay, and we write it as A inverse, and in this case A is said to be invertible. Okay, so if you have say A B equal to BA equal to I, then we write A is equal to B inverse. Okay, or B is equal to A inverse. Okay, now this applies only for square matrices. For a rectangular matrix, it does not have a inverse matrix. Okay, because AB product is not same as BA product, right? So that is why it doesn't apply for a rectangular matrix. Now there is a theorem, okay, which says it is uniqueness of inverse. Inverse of a square matrix, if it exists, is unique. Okay, so we'll just prove that. Okay, theorem, it is given number 3 in the textbook. Okay, let A be any square matrix of order m and B and C be any two inverses of A. So we are proving it by contradiction method. Okay, we are taking one A matrix and we are taking, that is assuming that, assume B and C both are inverses of A. Okay, then if B is the inverse of A, then we can write AB. Okay, I'll write here, if B is inverse of A, then we can write AB equal to BA equal to I, right? Now if C is also given inverse of A, right? So here also we can write AC equal to CA equal to I. Okay, now take B matrix. Okay, B matrix is there. Now B matrix can be written as a product of B and an identity matrix, right? Now we know from 2 that identity matrix can be written as AC or CA. Okay, so I'll write identity matrix as AC. Okay, now I'll take BA together and C outside. Okay, now from 1 we know that BA is also I, so we can write here I. So this is IC. So product of this is again C. Okay, so we have proved that C is equal to B. That is, this if two inverses exist, then they are same. Okay, that is, inverse is always unique. Okay, let's prove next theorem, which says that if A and B are invertible matrices of the same order, then okay, we have to prove that AB whole inverse is equal to B inverse product of B inverse A inverse. This we have to prove. Okay, so from the definition of inverse of matrix, that is, we have to prove now here two matrices, product of matrices is given, right? So I'll take, we know that A into A inverse, you will get I, identity, correct? So we'll take AB product multiplied with its inverse, which is our identity matrix. Okay, now multiply A inverse both the sides. Okay, now take this product together, A inverse A. Okay, A inverse A, we know that it is identity matrix, so this will be I, B, AB inverse, and A inverse I is again A inverse, right? Now I into B means you are taking identity matrix and a matrix, so you will get the product as B. Now multiply both the sides with B inverse. Okay, I'll write here only multiplying by B inverse both the sides. Okay, B inverse B is again I. Okay, and identity matrix with a matrix, you will get the same matrix. So this is AB inverse equal to B inverse A inverse, and this we had to prove. So we have proved. Okay. So you have to start with the product, that is you have to use this property A inverse equal to I. Then multiply both the sides with A inverse. Then you will get this, and then you have to multiply both the sides with B inverse. Okay. Next we are going to learn about finding out the inverse by using elementary operations. Okay, so inverse of a matrix by elementary row or column operations. Okay, so you have to just follow some process, okay, to find the inverse. Now I'll just explain how to do it. Now there is one point here, that is, in case after applying one or more elementary row or column operations, that is, for row you have to use A equal to I into A. Okay, for column you have to use A equal to A into I. Okay, this you have to remember for row and column. So if we obtain all zeros in one or more rows of the matrix A on left hand side, then A inverse does not exist. So if we obtained one or more zeros, all the zeros in one or more rows, okay, like this, if you get, then inverse does not exist. Okay, this you have to keep in mind. Now while applying row operation or column operation, okay, if you are starting with a row, then you have to go like this. You have to make this 1 first, then 0, then 1, and then 0. That is, you have to follow this process. Okay, for a column operation you have to go like this: 1, 0, 1, 0. That is, you have to apply, you have to go this way. Okay, So this you have to keep in mind.